All righty. Well, thank you so much, Tom and Jack, for the invitation to speak to you all today. So I'm going to be speaking really briefly about some what I see as industry developments in the potential use of virtualization for graphically intensive works of software-based works of art. So for those of you who don't know me, I am the founder of Small Data Industries, and we are a lab and consultancy based in New York City. And we are dedicated to safeguarding the permanence and integrity of the world's artistic record. And we do this through supporting and empowering people. So we fulfill this mission through consulting and services supporting our clients' efforts in conservation, exhibition, digital preservation, organizational growth and change, and capacity building. So I don't want to assume that everyone on this call, I know we've talked a little bit about virtualization here and there, but let's just do a quick refresher before we dive in. So let's say you have this whole mess of computers, each one a little bit different, configured a very particular way. Obviously, this is very impractical. So we're going to draw a little box over here, and we're going to call this box our virtual environment. And so what we're going to do is we're going to one by one place our computers inside of this virtual environment until eventually we're just left with our one laptop, and every single little quirky machine has been put inside of this virtual environment. And so we access this virtual environment on our laptop, and our laptop is called our host machine. And all of those computers which are now virtualized, totally immaterial, are called our guest machines. And of course, many of you know the platforms that one would be running on this host machine to accomplish this are VirtualBox or VMware. There's other options, but these are two very common solutions. Now, you wouldn't always necessarily be running these tools on your actual laptop or your desktop or whatever. In the enterprise, it's very common that instead you would be running them from a data center, from your server room. So instead of running it on your laptop, it's running on a very powerful server. So your host machine is in fact in the data center. And then your laptop is what's called a client. So you access the host machine through your client. So the focus of today's case study is going to be the artist John Gerard, based in Dublin and Vienna. Many of you are familiar with John's work, and I know, in fact, many of the institutions represented here hold his works in your collections. So John's installations, such as Solar Reserve, which you see here, installed at Lincoln Center, often consist of very graphically intensive pieces of software. He's used 2 different video game engines over the course of his career. And so whenever you see a piece of John Gerard's behind the scenes, there is, of course, a PC with powerful graphics capabilities. And so for our study today, we'll be focusing on an older installation of Gerard's sow farm. And the reason for this is because Patricia, who's on the call today, and Annette Decker did a phenomenal case study in 2015 on the potential viability of virtualization for the display of graphically intensive software-based works of art. So we very much see this as the starting point for our research. Many years have passed. So this is in some ways kind of an update on the state of the art. So I highly recommend, if you were not at Tech Focus 3, check out this Vimeo link and you can see their entire presentation at the Guggenheim in full. So not to be too reductive, but 3 key findings in their research were that 1, the virtualization tools available at the time in 2015 they were not capable of passing through the host machine's graphics processing unit, the GPU. So in fact, only VMware could even run the artwork. And this was only because it had a built-in virtual GPU or vGPU. And although VMware was capable of running the software, they found that the results were really not good enough. It was a very slow frame rate, and there's anti-aliasing that occurs in the software, or is supposed to at least, and the vGPU wasn't capable of reproducing this. So it really was not sufficient for exhibition. So in the intervening years, there, of course, has been exponential growth in industries that are heavily reliant on the processing power of GPUs. These are just some of them. Something else that's not listed here are, autonomous vehicles, which are heavily reliant, of course, on machine learning. So there's been a real market demand for GPU-powered virtualization platforms, and so there is now a supply for that. So Paperspace is one of these GPU-powered virtualization platforms, and this is the one that we'll be looking at today. So people use Paperspace for any number of things, any number of applications: machine learning, 3D rendering, and unsurprisingly, gaming. So cloud-based gaming rigs are really gaining popularity these days, as it really, it gives gamers the ability to have incredibly powerful rigs, but no hardware to maintain or take up space. So if we return to our kind of architecture of virtualization, it now looks like this. Our host machine lives in Paperspace's server farm, which has a whole army of GPUs at its disposal. And we access the VM actually through our web browser. So anybody who's ever set up a VM can really attest to what a pain it can be. Fortunately, these cloud-based platforms have really eased this process. They've really designed the whole UX process of creating these machines. So the first step in Paperspace is to choose which data center you want to spin up your VM in. They have 3 data centers, one in Amsterdam, one on the East Coast of the USA, and one on the West Coast of the USA. I'm currently on the East Coast, so let's pick that one. They have pre-built templates in Paperspace, so I'm going to choose Parsec, which is their gaming template. And here I have the option of selecting what kind of GPU I want to use. They have different associated costs. I'm going to choose the cheapest one, which for right now, for the time being, is an NVIDIA Quadro M4000. So I select that, I click create, and 15 to 30 seconds later, I'm running Windows in my web browser. And I really can't, we're going to get into performance stats in a little bit, but I really have to impress here. It's kind of insane. Like, you really cannot tell the difference between this and a native machine. It's pretty strange. Of course, we have to install the artwork. So in Gerard's case, this is done with a kind of one-click installer, and then we run the artwork. And amazingly, first run, it just simply worked. So because this VM has access to a proper GPU, it is able to run smoothly. It's able to do the anti-aliasing. As you can see here, we can zoom in. Thankfully, John has this diagnostic heads-up display. If you're not familiar with the work, this text wouldn't normally appear when you're viewing the artwork and installation. But here we can see it's running at 60 frames per second, which is pretty good. And just to drive home the performance aspect, these tests were done on my same computer I'm running today, 11-inch MacBook Air, and I'm actually not even in New York City right now. I'm all the way up in New Hampshire, so I'm pretty far from the data center. And I ran these tests on, I would say, very entry-level basic consumer Wi-Fi. So not a very good internet connection. So I do want to show you video. Unfortunately, as we know, Zoom is very laggy when you try and do screen sharing with video. So here's a link. I also put this in the notes. Feel free to take a look at that after the talk. It's about an hour screen capture recording. You will notice that the frame rate in the screen capture recording is a little bit lower than 60 frames per second. It hovered more around 50, and I'll get into why that might be later. But that is based on our understanding of conversations with the artist and the studio, still an acceptable frame rate. So there is one pretty big issue, though, with Paperspace, and that is this little dot. So this is the Paperspace menu button. So this overlays your viewport, and it can't be hidden or removed. Now, that's only partially true. It can't be removed through just a simple click of the button. But for the web nerds out there, it's really easy actually to just go into your developer console in Chrome and just remove it from the DOM. And we've even thought about maybe we should make a little Chrome extension that just removes it for you. That would be very trivial. But there's actually a better out-of-the-box option that we can use to get around this little pesky button. So of course, this is kind of our topology that we've been talking about. So it just so happens that the Paperspace gaming template comes with something called Parsec pre-installed. So Parsec is essentially a streaming service for gamers. So let's say I don't want to use Paperspace, but I want to be able to play games from my gaming rig when I'm traveling. I could install Parsec on my gaming rig at home and stream it from any device, any laptop. So because Parsec is installed on the Paperspace server, I can download the Parsec Mac OS client on my laptop and access it this way instead of natively in the web browser. So it's a little bit different. You are now using a software client instead of a web browser, but it does have some benefits, which I'll show here. So the client is only for Mac OS, which is one limitation, of course. But the real killer feature is this. So this is just a blow up of the Parsec, kind of their equivalent of the Paperspace button. You click the little icon and you get this. As you can see, the button can be hidden. You go full screen from here. It gives you some really great latency details. So this way, with Parsec, we not only get the frame rate as displayed by the artwork, but we can also see if there's any latency in the encoding or the decoding of the video stream that we're looking at or our particular network connection. So of course, 43 milliseconds is really, trivial. So we've here hidden the Parsec button, and really, I would say another killer feature of using Parsec on top of your Paperspace VM is that Parsec makes it kind of 100% resolution independent, meaning if we scale this window, the resolution stays the same on the VM. If we go full screen, it does not change the resolution of the VM. Whereas in Paperspace, when you're in the web browser, the resolution is dynamically adjusted. So if I resize my browser, the resolution of the VM at kind of the machine level will be adjusted natively to the precise resolution of my browser viewport. There's obviously huge benefits to that. There's real applications where that is desirable, but gaming certainly is not one of them. So that's another great thing about Parsec. There's no weird resolution interruptions if I go from this windowed view to full screen for exhibition. So circling back to the prior work in this space, all of Annette and Patricia's findings still apply here 100%, with the one major exception in this third bullet point, and that's that in this particular case of this particular artwork, cloud-based virtualization can accurately reproduce the significant properties of this work. There are some very specific pros and cons to this approach, so we'll just review these here with you. So pros is that in our tests, it shows this is definitely good enough for exhibition. Useful for assessment, but of course, it's always useful when you're assessing software-based artworks like this that are graphically intensive or hardware dependent to have, something that is a verified setup to test against. But this is where it gets really interesting. So you now have a way that you could potentially loan these kinds of software-based artworks without sharing the actual software. You could send the loaning institution a login to your Parsec account so they can stream it in the gallery rather than you giving them the software and them having to install it and configure it. So it's kind of good both for simplicity and also for security. You don't have to just entrust them with the files. So really, there's, with this approach, no need for any kind of expensive and complex computer hardware. Anything that can run a web browser and has a halfway decent internet connection really is good enough. And then the last thing that I'm just personally really, really interested in exploring further is that You know, these tools we're looking at give you direct access to the full machine, but there's also the potential here to add another layer like Twitch. You could potentially set up a completely non-interactive stream of these artworks where somebody can't exit out of the artwork and then get into the OS. And there's numerous applications for that. It could be loans, or you could even potentially stream these works, you know, publicly live on the internet for viewers if you wanted to consider a different way of showing these artworks. And I think, you know, with everything going on right now with the pandemic, that's of particular relevance. You know, the art world, I think we've all seen, is kind of scrambling to quote unquote go virtual, and it's, you know, not always very successful. And this is kind of a really interesting way where you can take these things that really you could only experience previously in person and put them online in a pretty interesting way. And this is something actually we're exploring with John, and so stay tuned on that. So the cons are, you know, this is not a preservation strategy at all. We view this as good for display and good for assessment. That's nothing particular to Paperspace. That's really identical to Annette and Patricia's findings, you know, in their study on virtualization broadly. Cons, of course, this costs money. It's not free and open source software. It is subscription based. You cannot export an image, but again, this is really not for preservation. It's just for display. This is a pretty big one. You can't move machines between regions. I'm sure they'll change that someday, but for right now, it's kind of a pain. You know, I've used Paperspace for teaching workshops in the past where we needed very particular software installed. And I like install everything in New York, and then it only dawns on me, oh, right, we're teaching this workshop in Europe and the connection will be really slow. So you have to kind of start over. And, you know, of course, there are no Paperspace data centers outside of Central Europe and the USA. So if you're in Australia, if you're in Southeast Asia, if you're in South America, if you're in Africa, you will have, I would say, pretty limited results. Circling back to cost, though, I do want to kind of dig into what the numbers look like here, because it actually is still viable, even though it's a new kind of cost. So in the case of the template that we were using for this case study, it's 51 cents an hour and $5 a month for the just the storage that the VM uses. And this works out to around, you know, $1,200 for 3 months running 24/7. So that's really a pretty trivial cost for, say, a loan. You know, there are fees that are much higher that museums are used to when borrowing works. So that's it. I'll leave it there, and we have plenty of time for questions. And I would also add, if any of you are interested in really exploring this further for your institutions or using this kind of technology to you know, make anything publicly accessible during the pandemic, we are more than happy to volunteer our time and services to help you with that. Thanks.
Thank you very much, Ben. That was super interesting. Do we have any questions for Ben?
Hi, Ben. This is Flaminia.
Hey.
Great presentation. I was just wondering if you could, for example, give if you have done any test in an exhibition setting, how they looked like, if you had any challenge that you encountered in using these tools for exhibiting work, because you're obviously having a really good argument that this can be, it's not a preservation strategy, it's more of a display strategy and technique as well. And I wonder if you were able to actually test this in an exhibition, and for how long, and where, and whether you find some interesting findings in this test.
Yeah, no, we haven't had the opportunity to do, you know, like kind of like real world long-term testing yet in kind of like real exhibition settings. That is definitely an important next step. And I would say there's nothing on its face that should be a problem, but of course, you know, when the rubber hits the road, that's when you find those things.
Okay, that's good to know. Thank you.
Yeah, thanks so much, Ben. That was really cool. I wondered if you'd like, what was that a particular version of Windows that you'd installed on Paperspace, or do you sort of have to install your own licensed version, or does it come with?
Everything comes pre-installed. You do have the option when using Paperspace to provide your own Windows license, but I honestly don't know why you would, because I've looked into it and it doesn't create any cost savings. I don't know if there's some kind of compliance, if you're using it at some kind of scale where that's more relevant, or if there's some kind of legal reason like on the user side where they would want to do that. But yeah, but no, it's a one-click Windows pre-install. There's also Linux templates. The GUI Linux template is definitely in beta. It's a little unstable, I would say. It's more for like a server.
So the big question: how far back do they go for Windows versions?
Yeah, they don't. It's like everything else we've been talking about today. This is all driven by the needs of industry, unfortunately, not preservation. Yeah, so I highly doubt that they'll ever roll out, Windows 95 on Paperspace, but that would be pretty cool.
I also have a question. It was a great presentation. Thank you.
Thanks.
I don't know, was that a GPU pass-through or not? Or in other words, does it matter what graphics card you have in your computer?
It doesn't matter what graphics card you have on your computer at all, because the VM that is running in Paperspace's data center has its own physical dedicated GPU, and that gets passed through to your VM.
Okay, thanks.
So that leads me on to a question though, which is because I know that we installed South Farm at Tate Britain with John Gerard, and I know how particular he was about certain sort of graphics card settings, and I wondered in Paperspace if you went through any like iterations of graphics cards and whether you like detected any change in the characteristics of the artwork as a result.
No, we didn't see. I mean, we looked at two different GPU options. We looked at the cheapest one. We looked at the most expensive one. The fastest, most robust one, and we didn't visually see any difference at all. And I do want to say, like, we haven't gone. We've sent the studio numerous screen capture videos that are like pixel perfect, and both John and the technicians have been like, it looks great, it looks perfect, that's exactly how it's supposed to be. But we haven't done any like rigorous benchmarks or anything yet. This is still pretty nascent, but they seem very satisfied with it, and understandably pretty excited.
See, Jonathan has his hand raised. Jonathan, have you got a question?
Yeah, great presentation. I was wondering if you had any research on the exact amount of bandwidth that you need or that you would recommend for this type of work. And then also if you were thinking about best practices in a real world environment to, have some kind of dedicated internet connection if you're actually exhibiting the artwork, 8 hours a day, or if you had thoughts about that.
Yeah, two thoughts. The network monitoring is definitely something we should do next. We haven't done that, but I've used Paperspace for a lot of different things in a lot of different settings. I've really never, the only time I've ever seen any kind of network performance related issues have been if I'm transatlantic, if the data center's in New York and I'm in Europe, or vice versa, if I accidentally create something in Amsterdam but I'm in New York, and that's noticeable. But everywhere else, I think just their video encoding is so clever that there's just like, it's kind of like I've seen some conversations on Twitter in our field about like, can you can you use H.264 for preservation of certain media? Like, is there actually a human perceivable loss in quality? And it's like a similar thing here. I think they're able to do such clever things with the video encoding and decoding that even, you know, in my experience on the worst of internet connections, it works really, really well. And then what was the second part of your question?
Basically, I was just asking about recommended practices in a gallery environment for maybe having like a dedicated internet connection or something like that.
Yeah. I think you would definitely want to have fail safes in place. Obviously, you would want it running on your internal Wi-Fi or wired internet connection, but always good to have a fail safe. So let's say you're running this on a Raspberry Pi, you could have like a 5G expansion card on that, so it has its own independent wireless connection. And 5G, I would say, would be more than fast enough for this application.
So have you tried any other what do you call it, workloads on it? It seems like, for me, this artwork is like the perfect thing to look good on streaming, whereas say a artwork that has more intensive graphics and changes will actually look worse and will actually be noticeable. So I think, have you done any testing on anything else?
Yeah, we're in the midst of testing Solar Reserve, which is far more graphically demanding. Obviously we need to test it and see what the data says and what our observations say and what the artist's observations say. But based on the kind of common use of the platform for gamers, I have very high expectations for its performance, because gamers are some of the most demanding and rigorous users imaginable when it comes to, the viability of graphical performance. You know, if something's like 55 FPS, then they're like, no. But yeah, the next one we're doing is Solar Reserve.
Okay. Yeah, so it's not so much the amount of graphics, it's more like how the graphics looks. So certain type of graphics looks better or, compresses easier, whereas some doesn't.
Oh, I see what you're saying. You mean more from like the video encoding and decoding side of things.
And just to clarify, it is video then that's being received.
Oh yeah,
what
you're receiving
it's a video stream.
Is a video stream. Absolutely. Okay. Mm-hmm. Yeah, that's the only way it could possibly manage to get that much through the network. Yeah, no, that's a very, very interesting thought. I think if you have any recommendations on good like test patterns or kind of like benchmark tests that would be good at kind of exposing those kinds of compression artifacts, I would love to
scrolling text. Scrolling that's probably one of the worst ones, because that will actually and it depends on how much.
I do wonder that whether it's presumably subject to some sort of like streaming codec, and then how the sort of very slow rotation of sound farm would work with that. It's like an interesting thought experiment, isn't it, to think about how temporal compression would work on a slowly rotating object like that. But I'm guessing that would be quite an efficient stream, which is very interesting. Do we have any more questions for Ben? Yeah, well, that was really cool. And thanks so much to all of the presenters as well. And yeah, that was such an enjoyable selection of presentations.